Cranking vacuum testing using the uScope and the FirstLook Diagnostic pulse sensor. So I'm going to do intake manifold vacuum with the uScope, and you have to identify a place to tap into your vacuum, into your intake manifold. Now this car already has a fitting right here that I previously put in here so that I can use this on a regular basis to do this test on this car. So I just need to pull this rubber cap off right here. The FirstLook pressure diagnostic sensor measures pressure changes as compared to a pressure transducer that measures pressure in comparison to atmospheric pressure. The diagnostic sensor uses the same technology to convert pressure changes into voltage values that can be used with any digital oscilloscope for diagnostic purposes. The difference is the inability to apply a scale that can convert those pressure measurements into an actual value. However, it is still effective in finding pressure and vacuum anomalies for diagnostic purposes. I connect the sensor to an intake manifold port, and I have connected the BNC connector to my oscilloscope. uScope settings, cranking vacuum testing, FirstLook Diagnostic Sensor Tool. To set up the FirstLook Diagnostic Sensor, I will be making a slight change to the settings I used with the Pico WPS 500 pressure transducer. Instead of using 0.2 volt per division, I'm going to change that to 2 volts per division. That is the only change. The rest of the settings are displayed on the screen. Let's make the test by cranking the engine over. Now that I have the waveform on the screen, press and hold the A button to save that as a new preset. Note the preset number is 092 so that you can rename it for recall later. Once again, I can zoom in vertically by lowering the amplitude value. However, the 2 volt scale appears to be the best scale for analysis. If I move over to the time sweep, I can lower that value to zoom in horizontally. Move over to the position button and press it once. Once it is flashing, you can press the left or right arrow button to scroll horizontally for waveform analysis.